Okay, so this is the last day of the unit before the test. And the last thing that we are going to do is transformations with graphing. So when you're asked to graph, you're going to be given something like this. So you've got the original function notation, and you have the graph of the original function. We need to pick points. It doesn't necessarily matter which points we pick. However, we want to have enough to be able to graph this accurately. So we're going to pick our endpoints, if we have them, and any place where the graph changes direction. Now we have space for 5 in the table. So since there's no other place where the graph changes direction, we can just pick whichever one of these points we want. Okay. So our original points are -6 and +2, -4, 0, 0, -4, 5, 1, and 9, 1. We want to get the table of our transformed function g of x, and then we're going to graph it. So we know in here we have x plus 1. Remember, that means the graph is going to go to the left one. So these are going to get, it stops hiding me, it's going to get 1 smaller. Now we need to do our y values. So our a value is 2, our d value is -7. So we're going to multiply each of those by 2 and then subtract 7. So these are those numbers here. -7. And make sure it's easier to put them, to do the points in order as they appear in the table for f of x, because you want to make sure that the correct x values are going with the correct y values, so that the same pair is ending up together in the transformed function. And then we know that last one's going to be -5 as well, because both of the last two y values were +1. Okay. So what we're going to do from here, I'm just going to pick another color, is we're going to graph this. So we have the point -7, -3, -5, -7, -1, -15. That goes off our graph a bit. That's okay. If that happens, just kind of estimate where it should be. 4, -5, and then 8, -5. From there, we connect them to the best of our ability. And we're going to label this g of x. because that's the function that we just graphed. Okay. So same deal here. We're going to pick some points. So we do want to pick this one down here because that's where the graph changes direction. And then we want to make sure we pick points on each side of this so that we're graphing both sides accurately. So I'm going to pick these two. And then I'll pick these two. So that is -3, 3. -1, 1, 0, 0, 1, 1, and 3, 3. And if you pick different points, that's okay, but you do have to pick where it changes direction and points from each side. And points if there are any. Otherwise, it does not matter. So on that first one, we didn't have to pick this point. We could have picked any of those points along one of these lines that we hadn't picked already, and that would have been okay. And same deal here. So if we picked -2, 2, that would be okay as well because that's still a point on the graph. And we've already picked all the points we have to. So we've got the one where it changes direction. There's no endpoints. So we can pick whichever other one we want. Okay, this graph is going to the right 4, so we are going to add 4. And then A value is 1/3, there's no D value. So we're just going to multiply these by 1/3. And we know that's going to be 1 as well because the Y value is 3. And we know these two are going to be 1/3. Because they both started out as 1. And then that one's going to stay 0 because anything multiplied by 0 is 0. Okay, so now we're going to graph our transformed function g of x. So we've got the points for 0, which is going to be over here. We have the point 1, 1. Three and 1/3, so over right here. 5, 1/3. And then 7, 1. Label it g of x. There we go. So we need to pick this point here because that's where the graph changes direction. Excuse me. And then we want to just pick points from each side of the graph. So I'm going to pick -2, 4, -1, 1, because those give me whole numbers for my y value. 0, 0 is where it changes direction, so I have to have that. And then same thing with 1, 1, and 2, 4, those are whole numbers, so that'll make it easier. Okay. There's nothing happening inside of the parentheses, which means that our x value is not changing. However, we have a -5 outside and a +11, so the y value is going to change. So we'll multiply each of our y values by -5, and then we're going to add 11. Okay, so -5 times 4 is -20, plus 11 is -9. -5 times 1 is -5, plus 11 is 6. So we know that that will be 6 as well, and that will also be positive. Yeah, -9. -5 times 0 is 0, plus 11 is 11. Okay. So, gonna graph this. So we have the point -2, -9, -1, 6, 0, 11, 1, 6, and 2, -9. Okay. So I'm going to make sure it's curved there and then do my best. That went pretty well to get it all the way down there without it being too squiggly. And label it g of x. All right. So this time it changes direction a lot. So we're going to pick our endpoints for sure. And then we've got 3, 4 places where the graph changes direction. So we want to make sure we do transformations on all of those points so that we know exactly where the graph is going to start and stop and where it's going to change direction when we transform it. So we have the point -8, 2, -6, 2, -4, 4, 2, 4, 5, 1, and 7, 5. Okay. Graph is going to go to the right one, so we're going to add 1 to each of these. And then the y value is going to get multiplied by 4/3. We're going to add 5. Four-thirds times 2 is 8/3. 5 is the same thing as 15/3 because 15 divided by 3 is 5. And so we know the next one's going to be 23/3 as well. For graphing, it can be better to take that extra second and convert that to a decimal, or at the very least a mixed fraction, so that's 7 2/3. Because that's easier to plot on a graph than 23/3 is. Okay, so we get 31/3, which is 10 1/3. which means this one will be 10 1/3 as well. Four thirds times 1 is 4/3. Plus 15/3 is 19/3. 19 over 3 is 6 1/3. 4/3 times 5 is 20/3. Plus 15/3 gives us 35/3. So we have -7, and then 7 2/3, so that'll be about right there. And go. -3, and then 10 1/3, so right there. And 3, it's 10 1/3. 6 and 6 1/3 here, and then 8 and 11 and 2/3. Label it g of x, and there we go. Okay, last one. So we want to pick that point so we know when it gets a little squiggly. Otherwise, it doesn't matter. I would pick points that are whole numbers because that'll make it easier. So we've got 1 1 and -1 -1. Then we've got 8 2. And -8 -2. We know that this graph is going to go right 4, so we're going to add 4 to each. A value is 1, so nothing will change there, but we do have a D value of 3, so we're going to add 3 to everything, or to our Y values. There we go. We're going to graph it, so -4 1 3 2 4 3 5 4 and 12 5 will be right about there. Label it g of x, and we're good to go.